Hey Vanessa, this is help with number 23 about recycling. It says, do most teens recycle? To find out, an AP statistics class asks a simple random sample of 100 students at their school whether they regularly recycle. How many students in the sample would need to say yes to provide convincing evidence that more than half the students at the school recycle? The Fathom dot plot below shows results of taking 200 simple random samples of 100 students from a population in which the population proportions who recycle are 50%. Okay, so let's take a look at this data and explain what the heck's going on with it. So each dot on this plot represents one sample of 100. So each dot on here is representing 100 students, and we have 200 dots all together. And that's kind of what's hard for some people to understand, is that every little dot on here, that's 100 students right there being represented. That's the percent of that 100 that sample of 100, that's their percent who said, yes, I do recycle. So we've got dot plots. Each dot is representing 100. Each dot is a different sample and the proportion on here. And it's important that each sample is the same size, the same exact population, and that's what they tell us, so we're good. So it says, suppose 55 students in the class sample say yes. That's out of the 100, right? So that's 55%. So let's say we had 55% in our sample. Does this explain why this does not give convincing evidence? Well, if you look at our graph, if you look at 55% and over, that's all of these dots right here, right? And if you count them all up, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. So when you do, this is 200 different samples, and of the 200 different samples, 43 actually had 55 or higher. So because that was so much, it's not like, it's not super common, but 43 out of 200, that's, like 21.5%. That's fairly common. That's not super out of the ordinary. That happens, 20% is 1 in 5. So about 1 in 5 times when you take samples, this is going to happen. And so because that's so common, common enough, we would say that we don't have evidence that this is way out of the ordinary, way high for this kind of problem, okay? So what we're really looking for is 5% or less. If it's less than 5% of these, then we would say, yeah, that's evidence, because that happens so rarely that it's unlikely to have happened just by chance, right? Okay, so that's part A. So you need to explain that first of all, you need to count these up and say 43 out of the 200 samples came out with these kind of results of having 55 students out of 100 or more. And because that's so common, or somewhat common, we don't have evidence that it's anything other than 50%. Because remember, this population is 50%. And the reason why not everything is 50% in here is because we're taking samples and there's variation in samples. So part B says, suppose that 63 of the students in the sample said yes. Explain why this is strong evidence. Okay, well, if you look at the graph, I actually circled it already, this white dot, that's the only one that happened where it was 63 or more. Right, I think that was exactly 63. So that's only one dot out of the 200 dots. So 1 out of 200 is less than 1%. It's actually 0.5%. Very small percentage. Definitely less than 5%, meaning if the population really is 50% that recycle, and if we got a sample like this, well, that is so rare that we don't believe that it's 50%. We now have evidence that it's probably higher. And I'm glad you asked about this problem, because this becomes a big deal later on.